This course that we are hosting is about post-harvest loss reduction for sustainable food systems. The reason we're having this course is because food loss and waste is a big challenge in our food systems, and we cannot have sustainable food systems when we are wasting a lot of the food that we produce that is meant for human consumption. According to the data from the Food and Agriculture Organization, in terms of fruits and vegetables, 40 to 50% of the produce goes to waste along the supply chain. The reason that food goes to waste is because the people that handle the food do not use the right post-harvest handling practices, and secondly, level of value addition to the food as a way of utilizing food that is not sold in the fresh market is not being done. So the purpose of this course, one, is to create awareness about the good practices in handling produce as a way of reducing losses in the supply chain, but also we look at the technologies that can be used to extend the shelf life, especially for fruits and vegetables. And thirdly, we're going to look at processing as a way of extending the shelf life by transforming the perishable food into shelf-stable products. So we'll be looking at the processing of fruits. The case study we're going to use for fruits is mango. And so we'll show you how we can actually transform the highly perishable mango fruits into a high-value product. So mango fruit will serve as a case study, but the same value addition that is done for mango can be done for other fruits. So the same practices that we're going to train you for mango can also be applied to other fruits. Then we'll be looking at non-crop commodities. We'll also have dairy. So we'll have to show you how dairy, especially fresh milk, can be processed into various products. You'll see how, first of all, the fresh milk can be treated so that it can stay fresh and in good quality for consumption. Then we'll look at how you can transform the fresh milk into yogurt, the natural yogurt, or the mango-enriched yogurt. We'll also do mala, which is fermented milk. How is it done properly? The food scientists will show you the cultures that can be used to add value to fresh milk. We'll also do cheese as another product from milk. So we'll be shown how to transform the fresh milk into cheese. We'll also show meat, especially in this case we're going to use pork. Meat can be transformed into other products, but we'll only, for this training, we'll only do sausage, which is a common product from meat.
I'm going to take you through the value addition of fruits with the case study of mangoes. Our fruits are sourced from farmers within the fruit growing zones and transported to the University of Nairobi cold storage facilities. Next, the fruits are transported to the food processing hub. Here they are received, sorted, washed, and weighed before processing. Next, in sorting, we select fruits based on the desired end product, in which we process either dried fruits or wet products. For wet products, we pick well-ripened mangoes for pulping in order to extract as much yield as possible. Here we pulp the fruits using commercial pulpers. The pulp is then pasteurized and it's used to process jam, juice, yogurt, and wines. For dried products, we use farm-ripe mangoes to process mango chips or crisps. We also use well-ripened mangoes to process mango leathers, which is dried mango pulp. I'll take you through pulping, whereby the sliced mangoes are taken through a conventional pulper, fitted with sieves that separate out the fibers from the fruit. to get a smooth pulp. The pulp is then pasteurized by heating to 90 degrees Celsius for 2 to 3 minutes so as to deactivate enzymes which may cause degradation of the pulp and also denature microorganisms which could cause spoilage of the fruit pulp, especially yeasts and molds. Next, the pulp is packed in airtight containers, and this can be stored at room temperatures or cold storage for further use, in which this can be processed into juices, wines, jams, yogurt, among other products. For juices, the pulp can be used to process ready-to-drink nectars, which are whole fruit juices. Here, you can formulate normal or standard juice or pulpy juice or nectar. We call it nectar because you have the whole fruit in it. Here, there is various variations of water and fruit pulp concentrations, added sugar, stabilizers, and also acidulants, such as citric acid. For pulpy juices, we mix 40 to 50% of the fruit pulp, with the remaining ratio being water, and you also add the recommended amounts of sugar, acidulants, stabilizers. We have come up with two standards for juice making. You can have a normal standard for juice, which is about 25 to 30% of the fruit pulp against 70% of the water added. We also add sugar and also other ingredients such as citric acid for lowering the pH, which helps preserve the end product against yeast and mold, as well as stabilizers. For packaging of the juices, we recommend packaging after attaining the right pasteurization temperatures, which usually involves different time and temperature combinations. Here you could use commercial pasteurizers, or at household level, use of large pans that are not heating directly the product, causing off flavors. This can be achieved by ensuring thick pans are used with consistent stirring, and temperatures recommended are a minimum of 60 to 65 degrees, and heating the juices to about 15 to 20 minutes, or you can go as far as 90 degrees Celsius for 2 to 3 minutes. For packaging, you have to ensure that the package used, which in most cases are plastics for juices, are within the temperatures that will not cause deformation, and these are about 55 to 60 degrees Celsius. But you only package juice after preservation. The packing process involves consideration of the packaging material and also the packaging temperature, and juices should be preserved while hot, in which we call hot filling as a technical term. This ensures that you disinfect the packaging materials by killing any yeast and molds which are inherent in the environment, and also ensuring that any bacterial remains are destroyed. The recommended temperatures is a minimum of 55 to 60 degrees Celsius, and this ensures that if you are using plastics, there is no deformation. Now we have the final juice products, which are cooled, labeled, and stored. For winemaking, the pulp is usually blended with water in a ratio of 50 to 50%, with addition of sugar to achieve 24 bricks. This is then fermented with activated yeast until the alcohol content of 10 to 13% is attained, and filtration takes place with subsequent bottling. For the fruit blended yogurt, the fruit pulp is usually pasteurized together with the sugar that is added to sweeten the natural yogurt. And these are blended in a ratio of 20 to 25% against the natural yogurt and packaged immediately after cooling. For dried mangoes, we usually process the fruits into either chips or mango leathers or rolls. Here, for the chips, we usually use farm-ripe mangoes, which are chipped in uniform sizes using chippers, and the best sizes is about 2 to 3 millimeters. And after which we soak in a solution of sodium metabisulfite at a rate of 0.5 gram per liter. This is to ensure that you preserve the color as well as kill off any bacterial and yeast attack that may come into the final product. The soaked chips are then spread on trays and dried in solar dryers for a moisture content of about 15 to 18% for stability. The water that we use for solution or soaking must be potable water, which is water purified through a reverse osmosis system to ensure that there are no microbial, chemical, or sediments that may contaminate the end product. The finished product, which are at a moisture content of about 15 to 18%, are stored in airtight containers, and these are consumed as snacks. For mango leather, we use whole fruit pulp, and it is usually a dried form of concentrated fruit. Here, we usually blend the fruit in order to obtain the pulp. And unlike in commercial pulping, whereby you separate the fibers, here the fibers are not separated. But to the pulp, we add sodium metabisulfite in order to retain the color and also preserve against yeast and molds and also bacterial infestations. The pulp is then spread on thin layers on trays, and this has to be uniform to ensure uniformity in drying, and dry them using solar turned dryers. The moisture content that is desirable is 15 to 18% for stability, after which you pack the product in airtight containers, and these can be consumed as snacks, and they are also shelf stable for a long period of time.
The pilot plant is very useful in terms of training, even when you are training college or university students, but even those who want to practice value addition and product development. And in the pilot plant at the University of Nairobi, we have got assorted equipment that can process different raw materials, converting them from the raw material to value-added, high or stable products.
So today we'll take you through the processing of kales, which is a representative of all the leafy vegetables that is common in Kenya. Now when you want to value add or to dry sukuma wiki, is a very simple process. You cut the sukuma wiki the way you just do cutting in your house. And then you first of all do what you call blanching. The process of blanching, which is the first step, is once you have cut the sukuma wiki, you immerse the cut sukuma, in boiling hot water. Usually you put the sukuma wiki in a sieve so that you put it in boiling hot water for a minute. And the purpose of that is to preserve the color. Usually in the blanching water, you can put in some salt as part of the way of fixing the color of the vegetables. So after you have blanched, you remove the blanched vegetables from the hot water and immediately immerse into cold water. The purpose of that is to stop the process of cooking so that they don't continue to cook after you have blanched. And then you drain the water and then you spread them on a surface. To dry, we have two drying options. We have the dehydrate, which is a new innovation for drying from Purdue University, geotechnologies. Then we also have the tunnel dryer. So the tunnel dryer, you need trays. So you actually spread the sukuma wiki on trays, and you spread evenly a thin layer on the trays. With the dehydrate, you can actually fill the dehydrate up to 3/4, but obviously that means you take longer to dry. But if you make thin layers, then you can dry faster, and then you can dry more rounds. Then of course, after you have dried, usually skuma on a good sunny day, it takes 3 hours, it will be dry. Then you need to just check, ensure that the moisture content is right, around 13% humidity. So usually if you look at the dehydrate tray, it comes with a humidity indicator. You can check and know that it's dry. Then once it's dry, you just remove and package them in an airtight bag. Usually it could be a punnet, or it could be a zip lock bag. You just put them, because important thing is after you have dried them, you don't want them to reabsorb moisture. So you ensure that you package them in an airtight container.
I want to take you through the process of tomato dehydration or tomato drying, as we all know it. Now, the process of drying is pretty a simple process, and it begins with the reception of quality raw tomatoes. And so when the tomatoes come in, you have to look at the quality of the tomato that you are receiving. If there is need for you to sort so that you get the right quality in terms of ripeness and even firmness, then you have to sort so that you take the good quality. After the reception and sorting, you have the good quality that you want to dry, then you have to take them through washing, and you can wash with chlorinated water. 1 ppm of chlorine will do for that washing. The reason for doing that is you are removing any contaminants, bacteria, fungi that may have come from the farm with the tomato. After the washing, then the next step in this case is for you to now slice into the required slices. You are looking at about 1 to 2 centimeters in thickness in slice. So after slicing, the next step for drying is for you to arrange them in the trays, and of course the trays are usually laminated with plastic nets. So when you spread them and you ensure they don't overlap each other so that they dry faster, then the next step is simply to take your tomatoes, and you can use either solar dryer or you can use an oven dryer. So because of the cost of energy, we advocate for solar drying. And the solar drying is better than the sun drying, because if you dry in the sun, the UV light will make some of the nutrients to be lost. But solar drying is very special. It preserves some of the nutrients. So then you will have to dry up to a point where they are up to about between 10 to 15 moisture content. And that is very critical. And that is one of the critical control points in dried material, moisture, ensuring that the moisture is as low as possible. Because between 10 to 15, you ensure that there is no mold growth when you store them or bacterial growth when you store them. And that way the dried tomatoes can last for a year if you package them well. Because after drying, then the next step is to package. So you would want to ensure that you package into a packaging which is sealed, that will not allow in moisture. Remember, our major trouble in dried products is to keep away moisture or water. So if you ensure that you have sealed and packaged tightly, then there is no moisture going in. Then you can be sure that this tomato which is dried, it can stay for about a year. And that you can then use to sell or use it as you want over the years. So you won't be worried about the episodes of lack of tomatoes because of the changes in season.
I will be taking you through processing of various dairy products, that is mainly yogurt, cheese, maziwa mala, and an extra product, a meat product, sausage. So for dairy production, we start by receiving milk from our farms, that's the university farms. When the milk arrives at the plant, we subject our milk to quick organoleptic tests, which means that we just smell the milk to check if there are certain taints in the milk. Once we have done that, we subject the milk to rapid tests, and those rapid tests include whereby we check for acidity. That means we check the level of fermentation. We back it up by also checking the pH. Once we have done that, we check the density to ensure that the milk is not adulterated. Once we have done that, we subject the milk to pasteurization. And pasteurization is whereby we heat and cool the milk to destroy pathogenic microorganisms. And to do our pasteurization, here we are supported by various equipment. That includes batch pasteurizer and can sterilizers where we'll put our milk after pasteurizing. So for pasteurization, depending on the product we are making, we employ different temperature time regimes. For a product like yogurt, we subject it to 90 degrees and we hold for 10 minutes. That helps us to condition the proteins in the milk, preparing for coagulation when we come to the next processes. If we want to make yogurt, we start by cooling the milk. We cool it down to 45 degrees. We incubate the milk with the yogurt culture. This is the thermophilic cultures. Basically, when I say thermophilic, I mean the heat-loving culture. So once we have inoculated, we incubate for a period of about 4 to 7 hours, depending on the prevailing conditions. We incubate at 45 degrees so that we can achieve this fermentation and the correct coagulum in the shortest time possible. Once we have obtained the fermentation that we desire, we subject the yogurt to a chilling process. This chilling process helps us to basically stabilize our coagulum. So once we have chilled our yogurt overnight, we come to flavor it, and this means that we do the addition of sugar and the flavors that are desirable, depending on what the market desires. Once we have flavored and sugared our yogurt, we go directly to packaging. Once our yogurt has been packaged, we basically subject it to various other tests to ensure the quality is good. That means we check to confirm that the viscosity is okay. And we also do an organoleptic test to ensure that the additives that have been added are up to the level required. We also occasionally subject it to lab tests, basically to ensure that there are no harmful microorganisms in the final product that is ready to consume. Also, in the same tandem, after pasteurization, the milk can be used to make a fermented milk product commonly referred as maziwa mala or maziwa lala. Yes, that is the fermented milk as we know it. This milk, again, because we are going to ferment the milk, we subject it to the same pasteurization conditions. Once we have pasteurized, we cool it down to room temperature at about 30 degrees, and then we inoculate with the mesophilic culture. It is different from what we use for other products, is particular for this product. Again, once we have done that, we subject it to a chilling process to stabilize the coagulum. And when the coagulum is stable enough, we subject it now to packaging. This one is not flavored. Many clients prefer it in its plain state. For cheese, instead of pasteurizing, we thermize. We heat up to 62 degrees, hold it for 5 minutes. You don't entirely heat the milk, because if you heat the milk, you denature the proteins. That heating allows us to reduce the microbial level. Once the microbial level is reduced, we cool it down to 33 degrees, basically the reneting temperature. At the reneting temperature, you add acidulants and the rennet that we use. So acidulants, you can add either a direct acid for some types of cheeses, but for other types of cheeses, you add a fermented milk, basically to introduce the lactic acid and the lactic acid producing microorganisms, which will ferment the lactose in the milk and be able to prepare the cheese for further ripening. So once we have renneted our cheese, we shall give it about 30 minutes, and within 30 minutes our milk will have curded. Basically means that our milk will have come from liquid state to a semi-solid state. At that state, we are able to cut the curd, and once we cut the curd, we release the whey. The whey is the liquid that you see in the milk, and the curd is the solid part that remains. Once we have the curd, we start a stirring process, basically to remove more whey or expel more whey from the curd. So we expel as much whey as we can from the curd. Basically, this is for when we are making hard cheeses. Yeah, so if we don't expel as much whey, our cheese don't become as hard as we want them to. Once we have the curd, we have the whey, we condition it further by also cooking. That means by changing the temperature. Altering the temperature helps to remove the whey and harden the curd. This curd, we subject it to a forming process, meaning to give it shape. We place it in a mold, and in the mold, we are able also to press it, to press further, to give it the shape and to expel as much whey as possible. Once we have the cheese formed in a certain shape, basically we vary the shapes depending on the types of cheese, meaning we use different types of molds for different types of cheese. So after molding, we subject it to brining. Brining is basically soaking in a salt solution. This one helps our cheese to form the outer skin. This outer skin will protect the cheese from molds and other microorganisms as it is being ripened. So after brining, we'll subject our cheese to a ripening process, basically about 6 weeks minimum. Yes, so after 6 weeks, our cheese is ripe and ready for consumption. What we are going to do today is to show you how to make fresh sausages. We prepare various ingredients in terms of the meat, which is our base ingredient, and for sausage to have the taste that it has, it requires some degree of fat, so we'll have in some fat there. And also we require some other ingredients in form of spices and binders or extenders. The spices will give us the various flavors that we know in our sausage, while the binders and extenders help to hold water in the sausage, to hold the fats and the proteins together in the sausage. Once we have our ingredients here, we shall start with our base ingredient, which is the meat, which you mince. We prefer to mince our meat when it's frozen. The reason why we do that is that meat might be having a lot of connective tissues, and these connective tissues are easier to grind when they are frozen. So we grind our meat when it's frozen. During the grinding step, if it's a coarse sausage, you use a coarser or a mesh that has bigger holes. If it's a fine sausage, you can either use a mesh with finer holes or subject the sausage to a further grinding or shredding process. So during the further shredding, you can either do it in two ways. You either do mixing, meaning you add in all the other ingredients and mix them in there, or you take it for further shredding and mix as you are shredding. Once you have shredded your meat, it comes out in fine form that you desire. Then you subject it to stuffing. That means that you fill the sausages into the casings. So these casings come in various forms. They are made of mainly collagen. So the primary ones for the primary sausages that we eat, the fresh sausages, are made of collagen, which is actually edible and can be digested. Might be of little nutritive value, but it's edible and can be digested. There are other forms of casing used to make other kinds of sausages. For example, if you are making the dry fermented sausages, which will take a long time in the preparation steps, you require a casing that is a bit tougher to be able to withstand that further processing. So depending on the type of sausage, it also matter the type of casing you use. Once the sausages are in the casing, you either link them, that means to fold them into single pieces as we know them, or as a whole as it is, subjected to a further process which is smoking. So after smoking, or the one that is unsmoked, these ones go directly now to packaging so that we can have the fresh sausages as we know it. So once we package it, also those ones are marketed as they are.
This session covers the handling practices for fruits and vegetables. We'll use case studies, tomatoes and mangoes and leafy vegetables. The purpose of this session is to show you good handling practices and storage technologies that are used to preserve quality and extend the shelf life of fruits and vegetables. We'll also be showcasing what we've been doing at the University of Nairobi, especially on low-cost cold storage technologies. So we'll have a session on the evaporative cooling technologies, the zero energy brick cooler, and the evaporative charcoal cooler. We'll show you how over time we have improved the traditional charcoal cooler to the current technology version of the charcoal cooler that is reinforced with fiberglass and has more hygienic quality compared to the traditional charcoal cooler. We'll also show you how we have improved the traditional zero energy brick cooler to the current version, which is more hygienic, one, and two, the structure is reinforced to the extent that you can actually maintain it over a period of time without it giving way as the traditional brick coolers do. When produce arrives at an aggregation or collection center, a lot of things happen. We assume whatever is coming from the field is high quality because whatever happens in the field affects the quality of the produce. Using tomato as a case study, when the produce arrives, we call that dumping. How it is offloaded from those containers is important. Care has to be taken that we don't inflict any injuries. The first thing we do is pre-sorting. And pre-sorting is a way of removing produce that has come that will not even go to the market or it has no use in the supply chain. So we remove either they're infested with pests or they're infested with diseases or they're badly damaged, so we do pre-sorting. After pre-sorting, we have now produce that is good enough for the market. So either we pre-cool this produce first or we straight away wash it. Washing is only encouraged if the produce that is coming from the field is dirty. The reason we don't encourage is because sometimes the wash water spreads the germs or contaminates the produce. But if you have to wash, then you have to use sanitizers. And the most commonly used sanitizing agent is chlorine, which commonly is called sodium hypochlorite. Commonly it is called jik. So for farmers, the way we train them is instead of them measuring, we just tell them use a cup of the jik, put into a bucket of water. So we wash the produce and then we dry it, then it is ready for storage. Now before you store, one, you probably want to ensure that you sort them based on the maturity. Yeah, so the ones that are still farm mature or mature green, in the case of tomato, we sort them separately from those that we call the breaker stage and then the ripe stage, because all these are for different uses and different markets. When you take them to the store, you see that we store them based on the stage of maturity of the grade. If you go to our store, you'll find that the mature green are on the extreme edge, meaning that they will be the last to come out. The ones which are red ripe or fully ripe are closer to the door, meaning that if you want to remove, you start with those. And then you go to the pink stage and then the green stage. So we sort actually based on what do you want. Is it for the market or is it for storage? Packaging is very important. We are either packaging for transport or we are packaging for storage. We are used to packaging using plastic polythene bags and sacks. Now that is really harmful to the produce because it's part of the reason that produce really goes to waste. First of all, we have bread crates, which is a common crate that we use. That is okay. It is good for storage and even for transport. But we also introduce you to nestable crates. They're designed in a way that the produce that is in the lower crate is not injured by the top crate. So they have space in between the crates, which ensures that the produce at the bottom is not injured. The normal bread crates, they are not stackable, meaning that if you fill your produce in the lower crate and you put another crate on top, it's going to injure the top layer of the produce. So the nestable crate is an innovation that is designed to achieve the purpose of minimizing injury on the produce that is being transported. There are various technologies that we apply to preserve quality of the produce. So this is active bag, and this active bag is specific for mango, meaning the permeability characteristics of this active bag are matched with the physiology of the mango. This one is a specific one for tomato. The zero energy brick cooler operates on the principle of evaporative cooling, and it is made up of 2 layers of bricks which are organized in a way that they allow space in between the 2 layers of brick. In between the 2 layers of brick is sand. Now sand is a medium that holds water. The way the brick cooler is designed is that there's a double wall of bricks. In between the double wall there is sand. Okay, now sand, we keep this sand wet, so you can see a drip line that actually from which water drips into the sand. Now how it works is that hot air from outside the chamber, it passes, you can see the way the bricks are organized, this air can pass in between the bricks. So the hot air coming from outside, it hits the sand, and the sand has water, okay? So the sand is wet. Okay, now this water that is held by the sand is heat, or rather the hot air heats the water in the sand. Now what comes inside the chamber is relatively cool air, and it's humid, okay, because it's carrying the water. So it's cool, humid air. Now that cool, humid air is what then cools the chamber inside. So inside the chamber is not only cool, but it's humid. Now when you bring in cool, humid air, it saturates the air around the produce. When you have an evaporative cooler like this one, it basically means the air around the produce is saturated with water. So the produce will not lose water to the air. The chamber is covered, which is important to ensure that you lock in the humidity and the coolness. But again, it's important that the excess humidity is absorbed by the cover. So the material that is used for the cover is absorptive material. And then the second thing we have done with our engineering team from the School of System Engineering is to actually improve the brick cooler by reinforcing it with steel rods. With the reinforcement with the steel rods, the structure is stable. One, it's stable so it doesn't fall apart. And secondly, what we want to do is to build a bigger structure, because this structure that we have here is just 2 meters by 2 meters, which is small. But the thing is, with this kind of reinforcement, you can actually build a taller structure, a 4-meter tall structure, which then gives more capacity for storage. Now the charcoal cooler, again, the principle is the same, evaporative cooling. Now the medium that holds water here for the charcoal cooler is charcoal, okay? We have introduced the use of fiberglass as part of the wall of the charcoal cooler. And the advantage you have with the fiberglass is that one, it is more hygienic compared to the naked wire mesh, and two, it reinforces the structure. It can actually is more durable because the fiberglass is more durable. It can even be hit by harsh environment, but it won't fall apart. So that is the innovation we have introduced for the charcoal cooler that we have developed at the University of Nairobi. So it is more hygienic, and it's more stable, and it's more durable compared to the traditional charcoal cooler. So another technology that we are going to introduce you to is the CoolBot cold room. The CoolBot is paired or is coupled with two other components to make a CoolBot cold room. So there's the CoolBot, which is the innovation, then we have an insulated wall, and then we have a compatible air conditioner. Now basically what the CoolBot does, when you have a CoolBot fitted to a compatible air conditioner, what it does, it just overrides the thermostat of the AC. Traditionally, usually the AC or the air conditioner is set, most of them are set to cool your room to around 18 degrees C. But what the CoolBot does, it overrides the thermostat and the settings of the air conditioner so that you set your temperature on the CoolBot. For example, if I'm storing mango, I want to set the temperature at 10 plus or minus 1 degree or 2 degrees C. So I set that temperature on the CoolBot. So what happens is when you turn on the AC and the CoolBot, the AC detects the temperature that is set on the CoolBot, and it achieves that temperature. And so if you set it at 4 degrees C, you set it at 10 degrees C, the cooling will, the AC is able to actually override the thermostat and cool for you the room to your set temperature of the CoolBot.